Okay, tonight we have to talk about rate of change and slope. Now these are two words or phrases that are almost identical. So let's start with rate of change. Your rate of change is how one variable changes compared to the dependent variable. So rate of change is the ratio of how maybe y changes, if that's your dependent variable, to x change. Okay? And I say rate of change when I'm talking about to maybe real-world examples, like how the temperature changes with time, sorts of things, okay? I'm just going to use x and y here for a general dependent variable and a general independent variable. So what are we saying? We're saying rate of change is delta y, a ratio, of course, can be written as a fraction, and this is rate of change where delta, this is a Greek letter delta, means change. Okay? So I know you're looking at this and saying it looks a lot like slope, Mrs. Finger, and it is. Alright, so what happens when you have a constant rate of change? Okay, so what happens is you have a table of values. Okay, so I have my table of values, and I want to discuss the rate of change with distance with time. And because they told me this was a constant rate of change, then I can pick any two values. Okay, pick any two values, and you should get the same value for your rate of change. So what am I going to do? Let's look at this and say delta y over delta x is equal to y changes from, let's see, 204 minus 68. Okay, I'm picking these first 2 points, and the x changes from 3 from 1. So if you work all that out, I'm getting 136 and 2, which gives me 68. So 68, and here, because it is this nice units involved with this, I'm going to put miles per hour. So there's my rate of change, 68 miles per hour. So for every 1 hour change in time, my distance changes by 68. Now this is otherwise known as a speed, right? So we're kind of going back to something real familiar here. Let's see what else happens with a constant variation, or a constant rate of change. Okay, so again, let's pretend we know that we have a constant rate of change. This one's going to be filling up your swimming pool with your hose. You know, you turn it on to a certain place, you leave it there, so you're filling at a constant rate of change. How much does the volume change per minute, right? So this time we just want to be able to calculate it by a graph. And when you have a graph like this, you know it's a constant rate of change. So because it's constant, you can pick any 2 points, just like a table. So let me put 2 points on here for you, and I'll let you calculate the rate of change. Okay, so I have the point 3, 108, and the second point is 7, 252. I want you to calculate that rate of change. Pause it. And it comes out to 36 gallons per minute. So every 1 minute of change in time, I have 36 gallons change in the volume. All right, let's see what happens when you don't have constant rate of change. What can we do? Okay, so here's something where it's not a constant rate of change because, you know, maybe the temperature overnight, how it was changing with time, dropped in a hurry, didn't drop so fast, then it dropped in a real big hurry. But it's not the same. So what you have to do in this case is use the endpoints, okay? So I'm worried about the average rate of change between 2 times, okay? Between t equals 0 and t equal, in this case, let's use this one here, which is 1, 2, 3, 4. T equal 4, okay? So I'm going to use these two endpoints. I'm going to use this point, and what I'm going to do, watch this, is I'm going to pretend that it's a straight line between them. Okay? And that is your average rate of change. Okay? So let's see what happens with those endpoints. Let me put the rest of the values on. Let's say I went at time equals 0 from 20 degrees. Let's call it Celsius, so it's not so cold. And let's go to, at time t equal 4 hours, maybe this is after midnight or something, to 0 degrees. So go ahead and calculate the average rate of change using those two endpoints. And if you do the math, you come up with the average rate of change is -5 degrees Celsius per hour. And you want to be careful because we do have a decreasing rate of change. The temperature was getting lower and lower, that you do have a negative rate of change there. Okay, that's expected, and we're going to make that work out. Okay, so here's what you've all been waiting for, slope, okay? Dun dun dun. And the idea here is that, yes, we have been talking about slope, but we have to make sure our context is right. We were talking about two variables, like, two quantities, like time and minutes, temperature or distance, things like that. So those sorts of things have rates of change, whereas a line is described as having a slope to a line, okay? And we're always going to use our x and y here, but it is the rate of change for the line. So we're going to use m for slope, okay? And we'll use our definition that we had before, delta y over delta x. That works still, because we have an x, y coordinate pairs on our line. But let's go ahead and go further in making sure y2 minus y1 over x2 minus x1. This is making sure we keep things in the right order. So, what's important to remember? It's important to remember that y's on top. So the top is y. Don't ever put the x on the top, that'll be wrong. One way to remember this is another word for slope is rise over run. And then the rise is how far it's going up and down, so the y, okay, rise is for up and down, is for y, it's going to be on the top, and the run, of course, is side by side. Okay, so rise is going up and down, run is going left and right, keep it straight. The other thing to remember is these have to be in the correct order. You're always taking the second number minus the first both times. I don't care if you do it the other way around, but you have to do it in both places. So let's do some examples, okay? There's a couple ways I can ask the question. I could say find the slope given 2 points. So what am I doing? I'm giving you the x and the y value. So let's say I had 2, 0 and -3, 5. Could you find the slope between those lines? I want to show you my way first. I keep it nice and tidy. I keep my y's on the top. Okay, and I'm going from the second one and then to the first one. And then I'll draw a line for the x's that is on the bottom, keeping track of x's are on the bottom. And I'm going in the same direction. Okay, so my m is going to equal 5 minus 0 over -3 minus 2. Hey, that actually came out pretty nice. M is equal to 5 over -5. M is equal to a -1. Okay, and we just want to reduce that like that. All right. So you can try another one on the next page. Okay, before, where I gave you the 2 points that were on the line, so then you could find the slope of the line that connects those 2 points. Here I'm giving you a line, okay, and I'll have some gradations on here for you. And I'm saying, okay, here's the line. You find the 2 points and tell me the slope of the line. So all you have to do is read your values. This is going to be 0, 3. And this one's going to be 3, 0. So I've picked my 2 points. I can pick any 2 points I want. It doesn't matter. This is a constant rate of change. And I'll go ahead and I'll set it up in a nice way so I can use that nice arrows to keep me straight. So I make sure I get my negatives and everything right. I'm going to use m is equal to 0 minus 3 over 3 minus 0 minus 3 over 3. M is equal to a -1. Oh, I did that again. Wow. But you get the idea. this idea where I can give you 2 points, what I did before, if I can just go back, is I gave you 2 points. I can't remember where they were, but say I gave you this point and this point. So it was up to you to say, oh, I could draw a line between those points, and the slope of that line would be the change in y over change in x. Okay, and now, this time where I give you the line, you have to find the points. So either way works fine, not a big deal. Okay, I want you to try one, but this is going to have to be an approximation since I don't have a really nice graph paper. It takes a little too much effort for me to import a graph paper grid. But just go ahead and give me an approximation of the slope of that line. Pause it. I came up with the 2 points 3, 6 and 0, 4, pretty close. And so that gave me the slope of 2/3. Hopefully that's what you got, and we'll be doing lots more practice about this in class, okay?